Hello, beautiful nerds. My name is Monty Paulson. I lead the Passive House team here at RDH Building Science, and it is my privilege to welcome all of you to the Global Passive House Happy Hour, hosted by Passive House Accelerator. This is an inclusive gathering. We welcome people from all Passive House communities. We welcome people interested in electrification, in embodied carbon, in climate adaptation, in indoor air quality, and oh yes, that task of retrofitting billions of buildings in our lifetimes. So please turn on your cameras. We really like to see you. Please turn on your microphones for a minute. We want to make some noise together. Please raise a glass and join me in a toast to staying home again. This time is going to be fun, damn it.
Cheers, everyone.
Cheers.
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 And Monty,
practicing.
I think we have to do a happy Thanksgiving sip toast as well to all our American friends. So happy Thanksgiving.
Thank you.
Thanks,
Lloyd.
Absolutely. There's probably
Happy late, weird Thanksgiving.
Thanksgiving.
Thank you, Lloyd. I appreciate it.
This is the best Thanksgiving for me.
Why is that?
I'm with the whole, I don't know, because you know me, I'm very, very far away from my family. So in a lot of ways, you guys are filling in that void. So I appreciate it. So as soon as you can send me some turkey and stuffing, I'd appreciate it.
When I moved down to the States, I thought the entire country was celebrating my birthday very often.
Otherwise,
Nice.
It's tomorrow. So
Chung fan. I'm sharing my Chung fan with you and my KFC.
I'm
Like
sure that
KFC.
Sean will have Thanksgiving attire before we get to the question and answer in his video screen. So now, please mute your mic. Please close your phone. We have a great show tonight, including Neil Norris of Morrison, Hershfield. And now, allow me to introduce my co-host, Prudence Ferrer.
Hey everyone, great to see you guys. I'm really looking forward to a weird Thanksgiving. I'm actually going to do a Thanksgiving brunch instead of dinner. Anyway, I'm joining you all from Philadelphia, PA. For those who don't know me, I lead the Passive House practice for Morrison, Hershfield. And I'm super excited for tonight because my right-hand man, Neil, is on here. You get to hear some of the stuff that we've been working on. I wanted to introduce you guys to our video, another classic from Sean. Thank you, Sean. This one is from a recent trip he took to Fort St. John, and it has two of the most northern passive house projects in Canada. Not the most northern ones because there are some in Alaska. I lived in one of them. But we're going to see a single family and a multifamily, and these projects showcase the 5 passive house principles that ensure they keep the occupants warm and cool throughout the year.
Hey everybody, I'm in Fort St. John. Let's go check out a multifamily passive house and a single family. Let's go! Hey everybody, I'm at the Fort St. John multifamily passive house. This is the south facing, and again, it's winter time, so again, look at this low profile sun here. So, trying to get as much sunlight into this high performance building, and let's go check out some of the details. Alright, so here's the east and south facing, so lots of windows. High performance windows from Duxton out of Manitoba, so Canadian made high performance windows. Lots of light coming in, and you can see the Swagon ERV hiding up there at the top. All right, here's the west face, and so again you've got these solar deflectors because you want to stop the sunlight that would be coming in from the north face during the summertime, something you wouldn't experience in lower part of North America, but up here in the north you get it. And the HRV pipes, and you can see they got a little bit of northern weather up here. Here you can see the thickness of the wall, 2x6 construction, exterior rock wool with Sega products to make it airtight. Again, fiberglass windows. You can see the detail all the way up the building. Very nice. Here's north face, and not a lot of windows. Here you go, the ERV is in operation on a cold November day. Right, there's that building again. Just wanted to show you the Swagon unit on the rooftop. Here is one of the first passive houses, single family homes built in Canada. First one in BC. Let's go check out the 5 passive house principles. Beautiful door from Euroline. Windows up here from Cascadia Window. Thick walls that were pre-made from BC Passive House. Got a lot of prefab. Here's the south facing. There's solar panels that are hiding under the snow. Lots of windows to brighten up and warm up the home. Certified passive house with FIAS. And on the final blower door test, I got 0.33 ACH. All right, one last view of the building. Forgot a couple details. 1,900 square foot building. Passive house consultant was Alex of Markin Projects. Highly recommend you check out the video of Paul and Catherine that can show you all the beautiful interior finishes and details. Check it out. Bye.
All right, thank you, Sean. That was awesome. So we are going to go into breakout rooms here, and you all know the drill. We'll have 5 minutes to introduce yourself, say hello, connect with people. So on the Passive House Accelerator website, each week on Monday, we publish a Passive House Week in Preview. So you can access this information in that article on the Accelerator. We have a new, every Monday we publish a new podcast episode, and this episode is a really great one with my friend Tessa Bradley, formerly known as Tessa Smith. And she's based in Olympia, does some really groundbreaking design work at Artisans Group. So check that out on the podcast. The Passive House Canada Summit is the big Passive House event that's coming up. It'll be on December 8th through 10th. And it's pretty great that we all have access to it, whether we're in Canada or elsewhere in the world. And we're going to be harmonizing and kind of aligning some of our content with that summit. So it should be great and a lot of fun. We also have, I'll be talking about Construction Tech Tuesday in a little bit, but we've got upcoming events and socials, including the BS Friday with Dave Cooper and Mark Willey that you'll want to take advantage of, and lots of educational programming. So as always, lots on tap, even at this time of year. So enjoy. And with that, I'll hand it off to Monty.
Thank you, Zach. What an amazing amount of stuff coming up. It's like the conferences just never end. It's like a movable feast of Passive House conferences this year. So tonight's presenter holds a distinctive title. Neil Norris has compiled the world's greatest collection of construction's worst details. Let me explain. For most of the last 2 decades, most North American energy modelers either guesstimated thermal bridges and kind of calculated them in a clear wall value, or they used their own methodologies for assessing thermal bridges. And so if you went to one energy modeler and to another energy modeler and a third energy model, you might get 3 different assessments of the buildings. This mess, this lack of standards, was partly responsible for why so many LEED buildings for so many years failed to meet their projected energy targets. Way back in 2010, Neil Norris launched an ASHRAE research project to craft a methodology for building a North American practice for modeling thermal bridges. He did a bunch of 3D modeling of a whole bunch of conventions and published this in this big giant binder back in 2014. I remember how exciting it was to get this giant binder full of more than 400 details with many, many added cents. But because the purpose was to help conventional practice buildings improve their models, that binder was full of conventional details. There were a tremendous amount of details in there that had an exposed slab edge, either in construction or a balcony slab or something like that. A tremendous amount of details that had metric psi values in the range of 1. That's right, 1.0, not 0.1. Thus, Neil earned the title of the creator of the world's greatest collection of construction's worst details. Now, I should add the other thing that comes to this perspective is that I work for RDH Building Science and Neil works for Morrison Hershfield, which is close as we come as to nemesis in the building science world. So you should understand that my comments come in part from the perspective of someone who's a bit jealous. We really wish we had done the building envelope thermal bridging guide. It is a great contribution to our field. Now, briefly, Neil left Morrison Hershfield to work at Passive House Canada as an in-house technical specialist. And I thought, finally, he's come over from the dark side. And I worked alongside him with several fantastic projects for Passive House Canada. But then he went back to Morrison Hershfield, where he is expanding the thermal bridging guide and supporting fantastic passive house projects like the one we're about to see here. So we were reluctantly forced back into our relationship as frenemies. And so it is with pride and a bit of jealousy that I introduce our next speaker, one of North America's leading experts on thermal bridging, Neil Norris. Take it away, Newman.
Thank you, Monty. All right, let's get going here. And I guess the timer starts now. Is that the idea? Yeah, everyone can see that screen. So today I'm going to be talking about a project we've been working on called 825 Pacific Ave, what we've deemed Artscape. So this is a building that's put together by a bunch of different partners here. It's developed by Grosvenor. So this that's the property wing of I think the royal family there. So as Sean said, this is potentially the Queen's first passive house. And then the rest of the design team includes Integral, IBI, and Ledcor is the contractor. So it is located in downtown Vancouver and some other highlighted areas of the local Vancouver map here, but it's kind of nestled in a bunch of kind of fairly high-rise towers, and there's a whole bunch of other buildings that are going up in the downtown core that are all going up, several, 50, 60 stories up. So it's kind of this tiny little 7-story building that's kind of right at the base of some of these other towers. Now, Vancouver is a fairly temperate climate. Our average winters are about 5 degrees Celsius, sorry, folks in the States. But our design temp is around -5. So we do drop below freezing on occasion. And we get about 2,000 hours of sunlight annually. But because it's nestled in this building, between all these tall buildings, we didn't really try to approach it as trying to take advantage of a lot of that solar heat gain, because we knew probably wouldn't get a whole lot to begin with. Now, again, this is a smaller part of a larger development. There's a next door residential tower also being developed by Grosvenor. And so it was kind of put on as a requirement to build this kind of community space and to go passive house from the city of Vancouver. Because in the end, this will be turned over to the city of Vancouver to own, and it'll be operated by a nonprofit association. And the intent of this building is to really house artist studios and offices and an event space for gallery exhibits. Now, right now, the exact tenants and all the interior equipment and tenant fit out is not quite known. So we don't know the full operations yet. So that'll come up a little bit later. But so far, we have been pre-certified under the Passive House Classic, and it's about midway through construction at this point. So for the layout of this building, it's got a fairly narrow shape. But it's a pretty simple geometry. So it's very kind of square, rectangular shapes along the building. So there's not a lot of articulation or anything to worry about there. And then on the interior, we've got some very kind of open concept, again, meeting that kind of up to the tenant sort of approach. But the idea here is to really have an open concept. Now, where we started in the design, kind of going for passive house in this case, was want to get a good head start. So we looked at kind of at the glazing systems first. And this we're kind of settled on, it's Grosvenor, they're willing to kind of spend the money for this. So we went with the triple glazed fiberglass window. It's locally designed and manufactured in the Vancouver area. It's been passive house certified. And then we've got roughly about a 20% or just over 20% window to wall ratio. And it's kind of a mix of operables and fixed, so that we can still, take advantage of some of those, natural ventilation streams in the summertime. And kind of, you can see the spacing of the windows here and kind of the division of how many kind of operables to fixed windows that we have, just on a characteristics section. Now, the one thing that we really needed to kind of consider or figure out in that beginning design is that this was intended to be a non-combustible building. So if we're, based on code and life safety, if we're using a combustible window product like a vinyl or potentially a fiberglass window that doesn't necessarily have fire testing for it, then there needs to be some additional considerations in the design. So in this case, in our local codes, what it requires is that at least a 1 meter separation between those windows. So in case there is any kind of fire distribution, the flame spread doesn't quite reach up to the next combustible window. And then also to make sure that we have less than 40% overall glazing on that particular facade. So in order to do that, they essentially designed the windows to be kind of staggered to provide that 1 meter separation. And then we have mineral wool insulation on the exterior. So again, this was our particular code. Depending on where you are, there may be additional considerations, but this allows you to use some of these non-combustible or combustible windows that are a little bit higher performing than aluminum on a non-combustible building. When it came to the actual envelope of the actual wall system, we initially started off pretty thick. We were looking at about 10 inches of semi-rigid insulation on the outside, and then looking at, thermally broken cladding system, and then some interior insulation as well, simply because we really couldn't take too much advantage of the gains from solar heating just because of the project location. So this was quite, a thick wall, right? And knowing that, where the buildings are and adjacent to the adjacent buildings in comparison to the lot lines and everything like that, we were kind of struggling with that thickness and trying to come up with some other solutions. This is where kind of the advice or working with the contractor and the subtrades at this point to kind of optimize the envelope really came in handy. So the initial clip system we were looking at is a fairly typical one. It's a pretty good performing clip system. But when we approached the subtrade, they actually provided an alternative. So we went through a couple of different optimization kind of processes. The first one was we ended up changing the steel stud gauge on the interior side. This allowed us to kind of provide a little bit more strength for that wall. And that way we could space off the cladding attachment system a little bit further. So instead of 16 inches on center, we were able to go every other stud at 32 inches on center. And then the subtrade provided this clip system here that provided an improved way of holding up the cladding because of this kind of key-in system. It's able to take a lot heavier dead load or cladding weight on the front of it. So this way we're able to actually continue, be able to space off those clips even farther apart and still maintain the thermal performance that we're expecting. So with that, we're able to, and we made some additional adjustments in our PHPP model, but allowed us to essentially go from 10 inches and cut down to 8 inches. So now this was a lot more reasonable and allowed a little bit more space and reduce some of the construction costs and material costs. At the same time, because we have so much insulation on the outside, we have a little bit of insulation on the inside, we're actually able to kind of take a look at that hygrothermally. And instead of doing, kind of removing the interior poly and putting an impermeable membrane right on the sheathing, because of those ratios, we're not so much worried about anything condensing on the backside of that sheathing. So you can kind of see, we went through the optimization process. We kind of took a look at the different clip systems and found that yes, we could make this work with the proposed clip system. Now, when it comes to some of the detailing, the window details, we've really tried to push these fiberglass windows off the steel studs and reduce that thermal bridging and nestle it right in the middle of the exterior insulation to kind of minimize that psi value. So in this case, you can see it kind of in the top right corner, the way we've kind of set it up here. We were able to even get it down to almost essentially thermal bridge free for this head detail, right? The way that we've kind of set it up. Now, the one thing to consider is, we did have to put in some areas an additional support angle where it wasn't able to kind of align and tie back to the structure all that well. But for the most part, we were able to kind of get away with not having to do that when we took a look at when we went through the shop drawing process. Other details kind of that seemed to make an impact was the below grade transitions, where, just trying to figure out how far down to bring the insulation. We do have a large raft slab on the bottom, so they didn't really want to insulate all the way down past that. It becomes very, very difficult. So we tried to optimize and using thermal modeling, figuring out exactly the depth of that insulation where it has to go. And we can find it just really needed to come up to the top, and really beyond that didn't make too much of a difference on that linear transmittance value. And of course, there's a bunch of other details, kind of standard, wrapping the parapets with insulation, pushing the doors out. One in particular, just kind of wanted to mention to everyone that we're trying out here is, in a lot of cases, we need to have through wall flashings every couple of stories to kick out any water or rain that comes through our rain screen system. So in this case, we have so much insulation on the outside. We're not worried about too much water getting back there, but we still need something. So instead of using a continuous metal flashing, which is a linear, can have a pretty decently large linear transmittance across the face of a building, we're looking at doing some non-conductive or two-part flashings. So in this case, we have a peel and stick, a through wall peel and stick that's just lapped onto a kind of a shaved mineral wool insulation. And this actually does provide a decent amount of support for the system and still able to kick that water out without having to have a metal, continuous metal flashing going through the whole system. And it's a very similar kind of approach with the base of wall detail. And in fact, it's even easier because you can put a piece of shaved of XPS or whatever kind of rigid insulation that you have on below grade and really make that connection across the whole face. So in this case, we were able to greatly reduce that thermal bridging around the entire building. And because of the building shape really, and the height of the building, some of these stuff does start to add up in terms of that thermal bridging. So you can see here just all of our different thermal bridges that we've used, pretty low values in the most part. The greatest ones are I think the below grade ones and some of the screen supports on the roof, but they're very, very small linear lengths on the building. So that was found to be acceptable. In terms of lighting design, we tried to make it as efficient as possible. And then for the mechanical systems, we're using heat pump systems for hot water. We just found that provided a little bit extra help with the PE targets. And then on the other side, we're using a single centralized ERV system, which then goes and connects into another heat pump VRF, which then provides additional heating and cooling for each of the spaces. And you can see here our current targets. The heating demand is at 13, so we still have quite a bit of buffer, which is nice. And then our PE is at 117, so we're kind of edging a little bit closer, and we've just kind of left that buffer for anything else that kind of pops up during construction, right? So if there are additional change orders or anything like that, at least we know we have the room to play around a little bit. So we're pretty confident about being able to maintain this throughout the rest of construction. In terms of the actual construction, we've had a great partner with Ledcor. They've really put together a pretty good process for everything. We've worked with them to set up workshops with the trades and just make sure that everyone's on board with the whole approach when it comes to maintaining the air barrier, dealing with any kind of change orders or things that just come up during the construction process. One of the big things that was very, very helpful right at the start of the construction was to create a building mock-up. And so this was done to just take a bunch of these characteristic details, and then all the trades kind of came in, all worked together to build this mock-up so they could do the sequencing correctly. They worked it out between each of the trades to figure out exactly how they were going to put things together. And then obviously, the one thing that everybody always dreads to see on a shop drawing is, by others, where, something one group is doing, they assume somebody else is doing, and then potentially gets missed on site. So this helped work that out, where we're there with the contractor and the sub-trades that, all of those missing pieces were put together and given a responsibility to one of those groups. It was also very convenient because they used this mock-up as a first stage for an air leakage test. So we set the whole thing up with the air leakage testers, and it wasn't a quantitative one. They weren't getting an ACH out of this, but it was really to do a smoke test to really figure out, well, what did we do on these details that, was there something off? Was there something that was just pouring out smoke? So they were trying things like, where the clips went in, they tried to pull like as if on site, if they put a clip in and had to pull it out because they missed the stud or something like that and left a hole, could they patch it up correctly? Or what would happen if they, if something wasn't sealed the way that they thought it would be, and just see what happens with some of that smoke. So that allowed us to at least sort some of those kind of remediation pieces out very early on. Now you can kind of see here with some of the progress photos, here's the below grade getting installed with all the below grade insulation. Of course, we've all measured that out. And then as they've gone up the building, they've started to do some of the lower roofs and putting in place, place areas for thermal breaks and other pieces that have kind of been embedded into the slab. This is what it's like, I think, as of a couple of days ago. So they're starting to sheathe the building, and then on the ground floor and second floors, starting to put in some of those window systems. So the next steps will be at around level 3. Once that's all buttoned up and the membrane and everything is put on, that's when we're going to go through our first air leakage test for the first three levels. So yeah, that's the building, and I think I'm right on time.
Great job, Neil. Hey, I see Morgan McDonald's here from Leadcore. Is there anybody else on the call from Leadcore or from this project team? I just want to kind of throw it out there for the question and answers that there might be some other folks along with Neil on this. Sean, do you have some questions queued up?
I do. Just put in there. So Zoe, Christian, Harvey, Ian, Rob, Scott, and Bronwyn are already in the queue. So let's start with Zoe. Zoe, you there?
Yes, sorry. I
Norris.
was about to feed my dog, but now I am not.
You're live. Fire away.
I think my question was about the facade attachments or the insulation attachments that were they had those wires with them. What did the insulation install process look like with those wires?
Yeah, so it's actually fairly easy. It's just one little tie back that hits, it's called a power key. And essentially the insulation just kind of fits around. It's really, really thin, so it's not too much to worry about. So we're they haven't started that process yet on site, but I can, let me see here. Let me just show you. We've done mock-ups for that, and I can pull that up if you can still see my screen. So it just essentially fits in between each of these brackets, right? And you still have to use stick pins, especially when you space off the brackets by quite a distance. But
Neil, we only see your PowerPoint screen. We don't see your other screen.
Always. There we go. Okay. So there's the kind of the setup. It kind of nestles into the bracket system there, and the power keys only occur at at only one location on at every elevation, right? It's there to take mainly the dead load of the cladding. So it's I think it ties in usually right at the top, depending on how you've designed your cladding system. But it's just one row all the way across the building, and the rest of them don't have that power key attached to it. But really, it just fits right in, nestles in right up against it, and you still put your pins in.
Got it. Thank you.
Sorry, Christian is next.
Hi, question I had about the bracket or the clip you used to install the window to get the window from the framing into the insulation. What kind of clip you use?
So let me pull up this again. You can kind of see it here. This is a feature of the window itself. There's lots of these kinds of window systems that take this approach, but it's just a single tie back. Right here. So it's just a strap, a single strap that goes back and then gets pinned in back here, and then your air seal is at the back of the system. So it occurs at each corner essentially, and then along the verticals as well. And we're not too worried about that because it's kind of set back within the system. It doesn't actually produce that much of a thermal bridge for it, and we've got we've got all of our insulation kind of outboard here, so it has a very, very minimal impact. I don't know if I have any photos of that though. Does that answer your question?
Yes, I thought maybe you were going with a fiberglass item, but it's metal. That makes sense.
And I think, I'm not sure if it's required to be metal for combustibility in order for them to pass their S134 test, but yeah, I think most windows end up having that metal clip for that flexibility and structural attachment.
There's a couple of questions on that window, so don't go too far. We'll come back to it. But next we have in list Harvey wanted to talk about blower door.
Yeah, I am. Sorry about that. Yeah, I just can you just walk through? I know you said you're going to do a blower door test over 3 stories. Can you walk through what your methodology is going to be for that and what you're expecting?
Right. So once this area has, and they're going through this process right now, putting on the membrane, sealing it all up, essentially ringing it around the building. And because you can see here, what we have at the slab edge, we're right up against it. They're going to essentially membrane this up and kind of seal this whole thing off. So all we're going to have to do is then seal up the stairwells and the elevator shaft, and then test just the bottom portion of the building that is all buttoned up.
Great, thank you so much. Good luck.
Thanks. We're expecting the most airtight building ever tested.
Hey, you better knock on wood, sir. You're going against.
I thought that was Monty's house you were talking about in your flyover. Wasn't that the most airtight?
I believe it's the community center in Surrey. They've got 0.07. So, you know, Morgan and your team and Neil, it's a good number to shoot for. I'd love to see what that does to your PHPP model.
We were on that one too.
So you can take the accolades. No, good stuff. I mean, right now, again, you're pushing for 0 at this point. It's pretty awesome. Next in the hopper, Ian's question was answered. Rob, I think it was.
Hey, yeah, I hope it's the most airtight building ever built. I was interested in the mock-up and how far you took that. Like, did you take it over the top of the parapet? Did you take it down to the slab?
Yeah, so they built it in the parkade, so they were limited to the space they had available. But it essentially covers a window detail, the entire window system, a base of wall detail, a corner, and then just how the cladding system will be attached. So they have, the vertical tracks and the horizontal tracks. So that was kind of the approach, is try to get as much as possible into that. The parapet wasn't the parapet wasn't included in this one, but overall, we're not too worried about that. If you look at the kind of parapet detail, the membrane is going to come right up onto the concrete, so it's going to transfer that air barrier pretty easily through that system, and the rest of it becomes just kind of insulation filler. So we're not too worried about that particular detail.
Yeah, that's sorry.
You're always limited by the amount of mock-up space you can put into one. I know at the Clayton Heights one, they even did an overhang detail as well and included that in there. But it's great to actually have on site because it's also a good training piece. So if any new trades or new people get involved in the project, you just bring them down and you show them how the approach works, and that's a pretty easy thing to kind of show, because as you're going through the rest of the construction process, some things may be covered up or some things may be no longer visible. So this is a good way to kind of showcase exactly what needs to be done for all the building.
Yeah, it's a slick mock-up, Neil, and to the Leadcore team, it's beautiful. It's great. I think Scott had a question too about the mock-up. Scott Kennedy?
Well, mine was a pretty simple question. I was trying to figure out what that 3M clear product was, and if that was actually the final membrane, so you could see what was going on and where the penetrations were, because it's clear.
Yep, that's what is it, the 3015 impermeable. The trades really seem to like working with it because it is clear, and so you can actually see where the drywall screws are, right? Or the sheathing screws are into the stud, so you can aim your clips appropriately that way. It's nice to see what's in behind there.
So it's called 3M 3015?
I think it's the 3015. Yeah, I think there's a couple different versions, but I think that's the.
And that is what's going on the building in the final analysis.
Yeah.
Thank you.
So it's not bituminous based. It's just it relies on the film and then the adhesive on the back. And it does say it's still self-sealing, but we have a patching process just in case.
Yeah, Scott, I mean, around town, you'll see that on a lot of multifamily projects. It's either the Suprema's big broken product or the 3M. If you go to like Canby and Broadway, you'll see it both on like 5 different buildings. It's pretty unique.
So Neil, is that a vapor open or a vapor closed product? Because that's your vapor barrier as well as your air barrier, correct?
Yep. Yeah. So
yeah, it's closed.
Yeah. So the idea here is that because we have so much insulation on the outboard, that, you know, for our climate, it's about, it should be about 50-50, I guess, in terms of where that dew point's probably going to lie. But we have so much on the outside that we're not really concerned about it. So yeah, it's even though we have insulation on the inside, that's impermeable.
Yeah, I mean, actually, on the heights, we actually have about 1/3 outside, 2/3 inside, and that's on the roof, where we actually have moisture meters right on the plywood on the sheathing, no problem at all, even with the night skies. So I really don't. I think that 1/3, 2/3 rule, it could go 2/3, 1/3 in Vancouver. Different if we're in a cold climate, but we're not.
Yeah.
So I think it's fine. Yeah. Thanks.
Scott, we would agree with you, but you have to model it to verify.
And we did.
Okay, where we are, Bronwyn, Susan, Michael, and then we still got another 4 more questions. So Bronwyn, you're up next.
Thanks, Sean. Just a question to the team. It looks like this design would have been pretty easy to do as a prefab panel. Did you guys consider that? And just kind of curious to know, you know, what was the you know, what was the decision making process to go with site built rather than prefab panel?
So I can say a little bit of something about this, and then Neil and Morgan, you guys can jump in. So the contractor that's actually in charge of the walls, Flynn, they're in development with a system called Speedwall right now that is a panelized system. And this was actually sort of a trial run for them to work out some of the kinks of what the panelized system might look like. But this size building, because it's not using a crane per se, it's not really the right scale for that panelized system. The cost per square foot doesn't really end up working out that well. But the system they are working on is fairly similar to this, except for instead of it being a site installed mineral wool, they're using essentially a king span, either the mineral wool king span, or they've got the quad core. Depending on your fire code rules, you can use one or the other.
Yeah,
Thank
that's
you.
good, Prudence. And further, but even before Flynn was on board, we did explore it. We've got a pretty strong offsite and panelization lead at our team here in Vancouver. And yeah, not only the number of panels that would have been, but also just the layout, that the facade had been designed and signed off and agreed to, and there were some elements of it that in a perfect world we would have modified to accommodate panelization, which was just not available to us. So we did not go that route.
What I'm finding so far in this marketplace is that a lot of the drive for panelized systems is coming mainly from schedule more than anything else. So you've got a lot of projects that aren't looking at it from a cost savings perspective, but mainly just to meet a specific construction schedule.
Yeah.
I mean, the good thing about them is in a sense, they become pre-engineered, you know, for a certain R value. You can get the panelized systems to say, okay, we want, you know, R30, R40, what do you need? And they can provide that without having to go through that kind of optimization process that we went through.
Yeah. And this project isn't really schedule driven because we're building the tower beside it at the same time. And so the tower really drives the schedule, and this kind of squeaks in adjacent to it, and it has some peculiarities to it that makes it not driven by pure standalone metrics that you might have on another project.
everybody. So moving along, thanks, Bronwyn. Susan had a question,
Yeah.
and then
Thanks, Sean. Yeah. So I noticed also that Kevin kind of had the same question. It has to do with, I was curious about how the trades were being trained, or maybe I'll ask it more specifically. Was it written in the bid documents, or what was the requirement for training to get people up to speed? Yeah.
So, I mean, Morgan, I don't know if you want to speak to this, but Ledcor essentially got a private training session done for this project to train up their project managers and a bunch of the sub trades as well. Is that correct?
Yeah. Yeah. Again, an unusual project. We had a long pre-construction lead time on this, like 2 years really. Because we knew it was going to be built, but the tower was really consuming a lot of that time. So I had already done the design, Passive House design course, and then myself and about another dozen folks took the tradesperson course. Sean was one of our instructors, and I've taken courses for Monty over the years and others, and we brought in some of the trades as well to join us. We were sort of all part of a cohort. And then, and when Prudence was in Vancouver, she facilitated a great workshop where we had designers and trades and us and the owner all sort of collaborating to work out some of the issues and those by others. Someone made that by others comment to make sure that everything, the boundaries of all the responsibilities were well understood. So we've had the luxury of time to do all of that, which has been really, really helpful, not only to get people educated, but to build up some awareness and familiarization and camaraderie as well.
Thank you.
One of the other things that we were fortunate to have was the use of the space at BCIT. They let us actually host our pre-construction kickoff meeting there, where there were mock-ups of various different kinds of walls, including the one that was very similar to what we would be building on site. So we were able to get the trades in the room with all the design team and the verification team, the blower door tester, and actually look at the mock-up that was at BCIT's classroom or learning lab and kind of talk through and touch. And that was actually where we figured out, like, hold on, we don't actually need two membranes. We don't need a permeable membrane inside and a non-permeable one outside. We can, the hygrothermal performance of the wall is such that, and just being there in person and talking through it all together really helped facilitate that integrated discussion. Totally.
Someone made a point in the comment about tactile learners. Some people don't speak up until there's something you can point to and touch, and those kinds of experiences are really valuable.
In terms of that, the mock-up, was that just because you had so much time, or was that also written into the bid documents as well?
Oh, we would have done a mock-up regardless, but here we had the opportunity. This is the parkade of the tower next door, so we had that space to work with, and a controlled environment, which was great, and private access. But we would have done one regardless.
So I guess to differentiate between there was an on-site mock-up, which is the one that you see here, and then BCIT, the space that we used. We actually we coordinated with Flynn, and they were able to build this and donate this to BCIT as a couple examples, not specifically for this project per se, but just as an idea of putting together a bunch of high performance details so that people can come in and check out exactly what that would look like on site. Because, there's a lot of, there's one thing to put it on a PowerPoint presentation, but to be able to come in and have trades look at what a system would be with all these kind of cutaways and can be quite helpful for them to understand.
And BCIT stands for?
British Columbia Institute of Technology. So that's our local college university.
Oh, it's a college, okay.
Yeah, we're lucky, Susan, with it's the High Performance Building Lab that got organized. I know Marcel is on the call today. Him and Sandra Roller were key in getting that started with Alex, who manages it. And so again, tip our hat to Marcel for making that happen, because it's a fantastic lab. And I think now we have over 16 mock-ups, as well as like an 800 square foot 2-story laneway house that has like every single detail you could look at in construction and how to air seal it. And we're lucky to have that.
Let me just add that more important than the toys is that BCIT is where most people go through to get their red seal and their other certifications. And so it was a very interesting strategic decision that was made in conjunction with Passive House Canada many years ago, that rather than keeping the trades training like the CPHD training and others, to move it into the same trade school that everybody went through. And so in addition to doing things like this custom course and others, you have lots of people who are just getting a regular carpentry degree who take 1 or 2 courses at the lab and have a little bit of exposure to all this. And so it has this spreading effect of bringing the knowledge across such a wider base. It took years to set it up. It was not easy by any means, but it's had a fantastic multiplier effect. And I would urge any other market to look at ways to take the trades training out of the passive house bubble and put it in the construction bubble, because that's what really starts to spread this stuff.
Thank you.
Yep.
There's one little last piece in terms of contractor training, and it wasn't really training, but I went for a couple of hours and sat with Ledcor's quality assurance team and Morgan and the project manager. And we just went through Ledcor's quality assurance plan, reviewing with an eye towards alignment with Passive House to make sure everything was in good shape, and talked about how they were going to integrate it in terms of working with the trades. And I think that helped them feel more comfortable with the process as well, because the Passive House trades training that we do have and that everyone currently goes through with PHI or FIAS, it's really geared towards the smaller buildings. And so I think, you know, there's still a gap that we need to fill in terms of bringing the construction management firms and the trades up to speed working with these larger buildings.
Yeah. Just a tip our hat to Pierre-Andre. I know he's out there listening, and he was one of the instructors that was teaching the Ledcor team. So again, we're really lucky to have Marcel and Sandra and Pierre educating people here in BC and sometimes across Canada. I mean, there's lots of people that come to BCIT to take the tradesperson course. So it's fantastic. Next up in the question is Michael. And I apologize, Michael, I forgot your last name, but I think Michael Cornegay. Michael, you with us?
Yeah, I'm with you.
Thank you.
Neil, great presentation. Just 2 questions for you. You showed the window detail, you showed the head. Do you have a detail that shows the sill of the window?
Yes, 1 second here, and I can dig that up. In the meantime, do you have a second question?
Yeah, the second question is, most window manufacturers, because each of the window systems have their own water management system, and I see at the head you've got the caulk, baccarat, air gap, so great water management detailing, but typically they won't allow you to push that window that far out unless you have some sort of water management panning system that you can put around it. So I want to know how you got around that, and did the window manufacturer give you any guidance toward how to install that window, particularly at the sill?
Yeah, so this particular window system, this is part of their drainage strategy. They have these kind of channels here that essentially allow it to go, any water that gets into here hits the sides and goes down. And then at the sill, we have, it's fully peel and stuck on the bottom so that everything kind of kicks out the bottom end. So with this particular manufacturer, the way that we have this design, they didn't have any issues with that water management.
So you have a sill pan, an extended sill pan at the bottom of the window to manage water out?
So let me just try to pull that detail off. So these are just trying to find it here.
I don't want to hold everyone up. I mean, you could probably. I'm sorry.
Yeah,
Michael, during the shop drawing, the integrated shop drawing workshop that we held, where we had all of the envelope trades and the design team and myself with the Passive House model open, this was actually something that we changed real time together from the architectural drawings, because the trades were saying, hey, we think we can do this cheaper if we move it a little bit, we can simplify this. And so we looked at what it would take and if it would be possible from a modeling perspective and also from a moisture perspective. And we had a technical rep from Cascadia there with us, working through it with us real time. So that definitely helped everyone feel confident that the solution we were coming up with was going to work.
Outstanding detail. You basically put that aluminum sill pan right in the accessory groove there. Wonderful detail for something like this.
Yeah, so this isn't aluminum down here. This is actually just a peel and stick membrane. Okay. So any water that gets into this cavity automatically just kind of gets, it can drain out the front side here.
Okay.
So there's nothing aluminum that's kind of cutting back into the back of the system, and then our air seal is all done at the back here.
Okay.
And Neil, just before we go to Zach, Nathan had a question just on the bracket there, the L bracket. Was that fiberglass or was that metal?
That's steel. So they're intermittent brackets that just hold up the window system. In the end, we were looking at having a wood buck in there. We like this idea of actually being able to push the windows out on a wood buck. They can still be structurally supported in, so even if this kind of goes away in a fire, at least it doesn't have a catastrophic, the windows don't fall off the building. But just for ease of things, I think you're able to bring your membrane all the way around, and then it just provide this structural attachment. Without this wood buck, it's still fine. It's not as good of a linear transmittance, but it still works out just fine. Now with this steel bracket, even with it placed there, it's still on the interior side, and then we were able to bring the insulation to cover the front face of that. So the impact of that steel bracket is actually pretty minimal that we found so far.
Hold on to that image because Marcel just asked a question, but we got to go to Zach. So Zach, over to you.
All right, thank you. So I'm going to share what's coming up next week. But before I do, I just want to say that everything that we do, so the happy hour, the Construction Tech Tuesdays, our summits and roundtables, our website, our newsletters, our podcasts, you name it, all of this would be impossible without the support of our sponsors. So I want to thank them here. Our founding sponsors are 475 High Performance Building Supply, Baxtingui Architects, Mitsubishi Electric Train HVAC US, RDH Building Science, StoCorp, and Zola Windows. Our stakeholder partner is NYSERDA, and our patron sponsors are Inotech Windows and Doors, Morrison Hershfield, and Partel. So thank you very much to all of our sponsors for making all this happen. So next week on Tuesday, we have Passive House Accelerator Construction Tech, same time, same place. Well, it's a different Zoom link, but the same time as our happy hour. And it's going to feature Matt Reisinger from the Build Show fame, and his colleagues Steve Basic and Jake Bruton, as well as Mark Willey and other co-hosts Sean St. Amour and Kevin Brennan. And they're going to be talking about this thermally broken deck as that you can see there on the right of the image, as well as other wall details in this really cool project in Missouri. So don't miss that next week. And I'll share a link to register to get the Zoom link. Next Wednesday, our happy hour will be visited by 4 staff from FIAS to talk about the new FIAS Plus 2021 certification. And they'll give us a preview of that certification and answer our questions about the certification and solicit input from us as a community. The public comment period for FIAS Plus 2021 is open until December 7th. So this is a chance to provide some comment on that. So very exciting. Please join us at the happy hour next Wednesday. And then Monday, December 14th, we're having our Passive House Prefab Summit #2. And this will be all new presenters and a little bit of a different format. Sean St. Amour will reprise his role as moderator, which is very exciting. And it should be super interesting, super fun. And we've expanded our capacity on the Zoom calls, so we won't sell out for this event. And I'll share the link shortly. Thanks.
Thank you, Zach. I just wanted to double down. The FIAS 2021 standard is on their website. So your huge opportunity here is to go read it in advance of next Wednesday's call and come with your questions, clarifications, complaints, requests, dreams to next Wednesday's call, because this is this great opportunity to kind of bring that up during the comment period with FIAS. Huge thanks to Neil, the whole team, to Morgan McDonald, the team at Morrison, Hershfield, and Ledcore, and so many others on this project. It was a fantastic presentation. And please stick around in the after hour, because Neil's going to talk a little bit about the thermal bridging guide and the opportunity to kind of share details through that. Prudence?
All right, thanks Monty, and thanks Neil. I know you've had a busy week, so I definitely appreciate you putting the presentation together and coming and joining us. I just wanted to let everyone else know. Also, I just realized we have Ivan Lee on the call, and he's one of our team as well, who actually does the 3D modeling along with Neil. So thank you guys for joining, and thanks Morgan. And let's roll on into the after hour for more questions and more thermal bridging fun.